Okay, let's start. Hi, hello. How are you today? Are you enjoying the conference? Yeah, awesome. So thanks a lot for coming to my talk about Spring Interface Clients that is not from this year, but we still feel like all the community doesn't know about it, so we would like to show it more and have people to try it and give us more feedback. Yeah, let me switch this on. Okay, better. My name is Olga Maciaszek-Sharma. I work on the Spring Cloud team where I am the committer of all the projects, but I mainly just work on Spring Cloud LoadBalancer, Spring Cloud Open Fain, Spring Cloud Netflix, and I've been also doing a ton of work to make Spring Cloud projects work with AOT and Spring GraalVM native images. And yeah, I also have been collaborating for some time with the Spring Framework team on the interface clients and have contributed a lot of the functionalities that I will be showing here. So what is a declarative client? Basically, if we have two services, a customer service, let's say, that wants to register customers, and a verification service, so the customer service will ask, hi, is this a real person or is this a fraud? Can I register them? And the verification service will respond with some kind of customer verification result. Now, there are many ways to do this in our class. Let's say we have some service class that is supposed to register people. And then what can we do? Well, the simplest way, not necessarily the best way, is just to take an HTTP client, put it into that class, do some kind of setup to set the URL and maybe some header, prepare some body, and just do a post and get a result. And then we can obviously do this for each and every call that we want to do to that service. So obviously, as you can imagine, that is not a way of doing it that I would suggest. And we can make it a bit nicer. We can create an interface, and in this way, first of all, we have known parameters. We have, secondly, known return types. More people can use it, more people can implement it and have different implementations for, let's say, different environments, testing, staging, and so on. And it's more readable, more usable, looks nicer, it's more friendly. And then obviously we need an implementation of this. So again, thanks to this, we can have different implementation. This one with REST template, we are doing all the same, but this will not, we will not be now be able to reuse it in any class that wants to contact this service. And obviously, we can now move a lot of the helper code to some utility methods, because if we are contacting that verification service, very often, even though, let's say, we are going to call different endpoints, but very often we will have some similar setup. So the base URL might be the same. There may be a subset of headers or cookies that will repeat, so we can move those. And then obviously we instantiate a class that implements that interface. So we have a verification service client object. And now in our service class, it is very readable and nicer. Now, is this a completely new idea? No. Can libraries and frameworks help us with it? Yes. So basically, what people always wanted is to just have this interface, paste some annotations on it, to be able to indicate what actually is going to be my header and what's going to be my body and so on, and then have a library or framework to actually do all these HTTP real client setup and all the calls under the hood. How is this done? So mostly what the libraries do is they take that interface, interpret it, and based on that, they create a proxy of that type. And it's the proxy that places the actual calls. And again, there have been some earlier implementations of this. A super popular project is Fain. Fain has like 9,000, more than 9,000 stars on GitHub. It is a neat project. And we also have Spring Cloud Open Fain that provides integration for it. This is the way that a Fain call looks like. So we have the interface, and then we have the request line, which is the annotation that will tell us what we actually want to do. So which HTTP method, what endpoint, any additional information can be also passed in parameters as the params one, and we can pass the body and so on. And then we have Spring Cloud Open Fain, which what it allows you to do is have the Fain client underneath, but kind of copy-paste all this Spring MVC server-side annotations and use them on the client side. So as you can see, we have post mapping that is the same. We have request body, request header, and so on. We also have the need Fain client annotation, and that allowed us to create all the auto configurations. So we instantiate all the beans, but not only we instantiate them, we also set up the load balancing for them, and we use this as a service ID. We set up circuit breaking if you so want. We set up tracing, and so on. Nice, many people use it. But some problems started appearing for us. So basically, there were three main problems. The first problem was that somehow enthusiastically, all the server-side annotations were now put to the client side. And it's awesome because you can take your controller, just copy it, paste it to the client, remove the bodies, and you have your interface client. However, if we look at this in more detail, actually the server wants to do more elastic things than the client. For example, if we have a request mapping, we might map various HTTP methods. In a client, we need to know exactly what method we will use, otherwise we cannot make the call. Same with the URL. The server can accept some sort of patterns, placeholders, wildcards, possibly serve various requests that start the same way but have a different ending of the URL. We cannot do this in the client. Also, Spring MVC has very server-specific things, like you can have a model attribute with a model attribute annotation passed in the arguments. You can return a view, things that didn't really make sense for us for this client, but the community kind of expected all of this to work, and we got issues like, okay, I copy-pasted, I removed the bodies, and it's not working. Why is it not working if it's working on the server side? Do we want to make it work? Do we want to have some kind of process where we try to think, oh, what did the user want to do? Maybe, but maybe no, because it would be very ambiguous and people would have different ideas of what it should do. So we took something, an annotation, that did something broader to use on something narrower. That was maybe not the best choice. Another problem that we had is that it is a third-party library, Fain core, and then Spring Cloud Open Fain is maintained by us. And the Fain core team is fantastic. They're really great developers, but they have their own schedule, they have their own priorities, and if we want to introduce something or have some issues, we don't necessarily get all the changes in core that would support it as fast as we want, because obviously it's a different team and they can do it this way. But since it was very popular, we would still just continue with it. However, a few years ago, as you may know, Spring put a lot of effort to make sure that we fully support the reactive stack. So we got the project reactor support, and in web we got web client and web flux, and we got RSocket support, and it was all added in framework. And then our users started asking us, okay, how do I do this with Fain? And how do I do this with Spring Cloud Open Fain? And can you guys provide that integration? So we started looking at it if there would be any way that we could possibly provide it. But unfortunately, the way Fain is created, it would need some re-architecting in the core Fain to allow us to handle this. So we started thinking what to do with this. And since it was coming out of the Spring Cloud team and we mostly did integrations, we thought, okay, if we use Retrofit, actually the underlying architecture is such that we can plug in web client underneath, and we can also use reactive return times so we can handle it. And we proposed it as an incubator project to handle any reactive request with a declarative clients and provide auto configuration and load balancing and tracing support and all the goodness that we provided with OpenFain. And then when it comes to RSockets, Josh Long created the RetroSocket, another incubator project, to create interface clients for that. So at some point we had many projects and we're thinking like, okay, do we move the Spring Cloud Square and Retrofit support out of the incubator? Do we take this RetroSocket on as a proper project? Do we join them? So we had a big call because on the Spring team, any major decisions are taken in a so-called leads call where the tech leads for different teams discuss things together with the people that bring up new topics. And then the framework team told us, you know what, we actually had an issue to create something like this, but we always close these kind of issues because we wrote them, okay, we have Spring Cloud Open Fain that integrates Fain, and it's perfect. There is nothing that it doesn't handle. And then we realized, okay, so we don't handle RSockets, we don't handle reactive HTTP requests, and maybe actually it's the time to start having something within the framework, especially that framework traditionally has always done things, has always handled HTTP communication. And made things easier to set up for developers when it comes to communicating over the web, so why not? And so in this way, the Spring Interface Clients project was created, came in 6.0. It is now fully usable. So if you want to use this, you need, well, let's start with HTTP and later talk about RSocket. But for HTTP, you choose if you want to use Webflux or if you want to use web. Firstly, we started just with Webflux support. Now we have both. And you have a new annotation, HTTP exchange. So this is the one that we have introduced to solve the problems that we have with request mapping. And we decided not to go into that corner again. It will be a tiny bit more complex because people cannot just copy-paste stuff. They will need to put this new annotation. But then they will also actually need to think, what is this that I'm really trying to do as a client? So we thought it would make sense. And then obviously you need an interface. And in that interface, you need to put methods that you will annotate with this new annotation. And it takes several attributes. You can specify HTTP method, or even you may need to, unless you pass it as an argument, which I will show. And you can specify the URL. And then when you instantiate such a client, which I will also show, you can just call the method, you get your result, and it translates to a simple get that we will do underneath from a proxy. Other attributes, content type and accept that you can put on HTTP exchange. Obviously, this will add either accept or a content type header. We also have shortcut annotations. So you can do get exchange, but you can also do all the usual suspects. And yeah, it's handy and nicer to use. When it comes to parameters, you can pass, first thing that you can pass is HTTP method. So actually, if you have an HTTP exchange, you either need to specify the method in the attribute, or you set a method as the argument. And then when you call it, you pass it, and you get the right method called. What is fun about this, it is that you can actually override the method during the calls. So even if you make a get exchange, but you allow passing the method as the argument, you can, while doing the call, decide to send it else, well, with a different method. You can also override the URI. So obviously, if you don't pass anything, you get the default one without any additional segments. But you can just pass your segments in the URL, as we have count above, but then you can set it as an argument. And if you pass the URI as an argument, what we will do is override the whole thing. So the call will only go to stats count and will not have another count appended to it. We ignore whatever was set in the attribute. And that was fun and well, but then people told us that, look, guys, we do it sometimes, but what we really do is to have the same end of our URL and the other segments, but just change the base URL because we want to do the same thing, but on a different machine or different instance, whatever. So we decided to address it. And now we also provide a way to change just the base of, override the base of that URL. And what you need to use for this is provide URI Builder Factory as your argument. So again, you can just use the default URI Builder Factory and pass a URI string. And then what we will do, we will change it. So let's say it was localhost 8081 in a base URL, but we can change it during the call. And that will be also helpful, yeah, if you want to work with different environments, for example. This is something that can be done. Another thing that we have added, and going back to this, if you see this kind of star icon, it is one of the newer things added over the past year. So as you see, we keep adding features to this. Another thing that we've added is to allow you to prefix all your calls from a given client with a certain segment of your path. So that's similar to request mapping. If we have this placed on the interface, it will always have the slash verification before whichever segment comes from the URL on method level. So that is also probably useful. And then we can do all the other stuff. We can pass the request body. And then as you can see, this is the same annotation that we use on server level. So while we didn't want to introduce this ambiguity and provide annotations that do more stuff in a different context, we wanted to reuse those that would do exactly the same. So a request body is a request body. It wouldn't behave differently in a client context versus a server context. So we reuse it. Obviously, the same goes for headers. And we can pass objects, we can pass maps, multi-value maps, or a collection of values. Obviously, we also want to handle any path variable, so you can use placeholders. Request parameters with the request param annotation. And there you handle objects. Again, maps, multi-value maps, or you can pass a collection of values. And the same types you can also pass with cookie value annotation to set your cookies. Okay, this is a fun thing. So for web client, another thing that is available in the web client itself is request attributes. There is also now an issue in framework for REST clients, so it is possible that it will appear in REST client as well, and then we will support it nearly automatically. I think there's like a 1 boolean that we need to change to support it in the interface clients. So if the request attributes are very neat if you are doing something, if you want to transform or further work with your request still on the client side. This is an example with web client, and web client allows us to implement exchange filter functions and in a kind of a group way modify whichever requests pass through. And the way it is done is if you implement the filter method, you can basically change your request, and as you can see here, we had one request, but then we have a new one, and we are going to send a new one. And this is an actual example from an issue that we got from a user. So basically the user said, I want to look for a request attribute named org on my requests, and if I find them, then I want to build an authorization header per given organization and add it for that request. And if I don't find it, I just want to continue with the request as it was. So request attributes, neat, useful, and soon probably also in REST client. And we have also been handling them from the beginning. You can add them for whichever client supports them. We also handle request parts, and you can either have them just set like this separately with a request part annotation, or if you give us a multi-part file, it doesn't even need to be annotated. We will see the type and handle it properly. And here you can also see the example of setting the content type in the attributes. Return values. Okay, so you can return pretty much anything that you may need. We have a normal concrete value. What you need to keep in mind is that if you do this, but your underlying web HTTP client is web client, so a reactive stack, what will happen is we do return this concrete value, but there is no magic. Somewhere it has to be blocked for us to return it. So yeah, what we do is actually call a block underneath. And you need to keep in mind that there are some scenarios where this may make sense, but mostly if you are working on a reactive stuff, it will not make sense. And even if you will try, for example, to call that let's say in a controller, you will get an exception because you cannot be blocking in that thread. So mostly we'll do this if you are working with web client, obviously Mono, Flux, and any producer that can be converted to a reactive stream publisher using a reactive adapter registry. So yeah, a Mono. And obviously if you have REST template or REST client, you will not be able to use mono or flux. Then we also provide response entity. So that gives you status, headers, and body, or HTTP headers, or execute only. Okay, how do we get this kind of clients? So at this point, this is a two-step process. The steps are two, but they are very simple and easy. So first, we need a service proxy factory, which is a bin that will be able to create a proxy. In this case, HTTP service proxy factory. Once we have the proxy factory, we can create the service instance bins. So in order to have the factory, we need an underlying client, because again, we are using whatever Spring already had. So we need either web client or REST client or a REST template, and we build it whichever way we want, or we have it already configured as a bin in our application and we can just inject it, or we can use a builder and, for example, use some setup from boot or some tracing, any additional instrumentation that we have, and just change whatever we need to change. And what usually we want to change is a base URL. So this will be the URL for the instance that we want to communicate with. And then we can just create a builder, and we wrap the client in an adapter. So we have web client adapter, and we will also see adapters for other kinds of clients. And then we build it, and once it's built, it's just one line. You just call HTTP service proxy factory, create client, and then we add, so the verification service is the interface that we've been looking at. So we add that signature, and it will be created for us. Obviously, if there is a builder for something, it usually means that there are more things that we can configure. So in this case, we can configure the embedded value resolver, add a custom one. So that is a string value resolver for resolving placeholders and expressions in the URL. Then there is a conversion service that is, what that's doing is formatting inputs as string. And these are all fun and well, but I don't think many people would change them. What is most important here is the custom argument resolver. So if you want to handle an argument, either a type or a specific annotation that we don't handle, but you have some custom scenario and you want to handle something else, it is very easy. You just need to implement the HTTP service argument resolver. And then you get the argument, the parameter, and request values. So basically what you can do is, first of all, check stuff on the parameter. What type is it? Does it have some kind of annotation? You can take the argument and you can transform it in any way you like. And then what you do is you add it to the request values so that it is accessible later on. And you can register a custom argument resolver like this on the HTTP service proxy factory builder. So yeah, it should be straightforward. It gives you a lot of flexibility in terms of your specific scenarios. And then obviously for REST client, we do all the same. We just have a REST client adapter instead of web client adapter. And again, we can also do the same for the REST template, just using a REST template adapter. Okay, so we've done this and we've released this, and people started asking questions. And actually one of the most frequently asked questions was, okay, this is all fine and nice, but how do I handle any errors if I want to handle them in my own way and not just end up with whatever default handling? And actually, since it is our infrastructure, you don't need to handle it on the interface client itself or in the proxy service factory. You can handle it in whichever client you are going to put in the adapter. So it's very easily done. For web client, you can just set a default status handler, and that will have a predicate on one side to decide what is this that we want to handle. So in this case, anything that has an error. And then you have a part where you decide how you want to handle it. So in this case, we are handling it with an exception. In this REST client example, we are handling it with logging an error. And again, it's the same method, default status handler. Obviously, can also be used on web client or REST client, not in the context of interface clients separately. But in interface clients, we are just reusing the infra that we have. And Obviously, we can do it also for REST template. It's pretty much same. The API is just older, but what it does is same. Tell me what is your error, and then what do I do with it once I have it, and then we use the set error handler method to actually put it there. Another very frequently used thing would be load balancing, because in any modern distributed system, the topology of that system will continue changing as instances are brought up to life and are killed, and we want a way to know where the new instance is or which instances we have, and then based on some kind of configuration that we've set, we want to be able to pick, okay, I have all these instances, which is the best one for me, so we want to use some kind of load balancing. And normally, we would use a service registry to find the instances. So for Spring Cloud, we integrate with Eureka, Consul, Zookeeper. We have Kubernetes support. And this is something that people ask about, because I think we speak about it less. If you do not have service registry, which usually it is not the best solution in production, but there are some scenarios where it makes sense, you can use a simple discovery client and just set up your instances in the properties, which is actually how this is set up in the sample. So if you're interested, you can take a look. And this is also good for testing, because you might not want to be setting up a service registry while running your tests. And then what we need is load balancer. So we just add Spring Cloud Starter Load Balancer. And that's basically most of it. The only other thing we need to do is we need to make sure that whichever HTTP client we are passing to it is load balanced. And to ensure that it is, we just annotate it. When we create the bin, we annotate that bin with load balanced. So for REST client, that would be the REST client builder, not the REST client bin itself. And then we just have to get that one. And if you have more REST client builders in your application, then you can use load balanced with the parameter, and it also serves as a qualifier. That's actually one of the things that people ask a lot about in Stack Overflow for some reason. And then the only other thing you need to do is make sure that your base URL doesn't point to an actual host or port, because you don't know which instance you want to contact yet. Instead, you use the service ID. So you put your schema, and then you put the service ID. And if it is HTTP verification, it means that the service that we want to talk to has its Spring application name set to HTTP verification. And if it's in Eureka, Zoo, or even Consul, or with Spring Cloud Kubernetes, it will register under this name. So then the underlying client will just get all the instances and pick the best one for us based on this. And that's it. Same for web client. We want to instrument the web client builder. And then the rest is same. But for REST template, this was created much before the other two, the instrumentation for that. And for those legacy reasons, it is REST template and not REST template builder that you annotate with load balanced. And now that I'm thinking about it, I'm wondering why we don't have the REST template builder. I think the reason is that nobody has requested it. So yeah, maybe we will have it. I might add it. But yeah, for now, you need to use the REST template itself. And then what about tracing? Again, so as you can see, the underlying theme in this presentation, the tracing is also handled by web client, REST template, which, well, makes for less things for me to show in this presentation, but I think it makes also for better experience actually using it. You don't need to additionally do any setup on the interface client. OK, HTTP exchange on server side. So for those of you that were paying attention at the beginning, you might be thinking, like, why? What is happening here? We just talked how this was a terrible idea to use the same annotation on the server side and on the client side. So since I've been supporting and maintaining OpenFain for many years, I was of this strong opinion that, yeah, that was a terrible idea. Let's never do this. And when people started asking us, can I use it on the server side? Can I annotate my controller with this? I was like, no. But then I talked to my colleagues in the framework team, and I talked to Rosen, and he has actually convinced me that it's a different scenario, because before we took something broader and more ambiguous and with more options and try to apply it to something more concrete and specific. And that obviously caused issues. But now we are taking something more limited, more specific, with only like one option. So we only have one method that we'll call, or only get requests from the specific URLs, or send requests to a specific URLs. So we are taking something with more specificity and applying it to a more open scenario. And the only thing it means is that if you use this and not request mapping on your server, then you only get whatever that brings. So basically, your server also has the same limited set of capabilities in the annotated mappers, but you don't really get any issues of like, it should do more than it's doing. So yeah, I decided, like, I agreed with him that, yeah, if you look at this way, it's not a bad idea, and then the team decided to go forward with it. But why would you even want to use it if you have the request mapping, which is by all means better for server because handles more things that you use for server? So the users told us that something they did with Fain was having the controller implement the interface, because then what you can do is kind of treat it like a contract. And do I specifically recommend it? No. I recommend Spring Cloud Contract if you want to have contracts. It is created for that purpose, because the way it is done here, it will introduce very tight coupling. But some organizations still decide, okay, for their purposes, for their internal APIs, this is what they want, and they just want to have this client, even on server side, share it with the actual clients, then implement this in the controller, and it is a strong contract. They are not able to call any other method. And then you obviously, in the implemented methods, you don't need to repeat all the annotations. They are already implied. So yeah, possibly a questionable thing to do. As I say, there might be better ways of implementing contracts, but sometimes it's used. An important thing, I would strongly discourage doing any such thing with a public API, but within an organization for an internal API, this may be what you need, because it's way simpler probably to start with than Spring Cloud Contract. But yeah, if you really want to enter into the contract realm and have proper consumer contracts, you should try Spring Cloud Contract instead. But anyhow, we decided it would not be an issue, and if people liked it, we could support it. So here it is. It actually, I think, required changing one line of code. So yeah, not a big deal to maintain. It's here. And another thing that we introduced together with the HTTP interface clients are the RSocket interface clients. So how many of you have ever used RSocket in production, in sample? How many of you know RSocket? OK, so I will do like a quick intro. RSocket is a very neat protocol. So basically, you have a protocol that takes the reactive stream semantics to the protocol level. It is fully message-driven and asynchronous. There is no client-server distinction. Like, you can send a request and response, but you can also have a channel. There are 4 modes of communicating: fire and forget, the traditional request response, a case where you send a request and you get a stream, or a channel, and it handles all the communication as a stream as a multiplex stream of messages over one single network connection. It is really neat. It is not very popular, and I don't know why, because I think it's awesome. It's very performant. And if your team doesn't work with reactive streams, probably it's like, you might not want to spend time doing this, but if you're working with reactive streams, and you have the know-how how to work with reactive types, it can be very handy to use. And Spring Cloud also provides a router similar to Spring Cloud Gateway, a router for RSocket. And it also handles already back pressure on protocol level, and it never blocks, and it supports TCP, WebSockets, and Aaron as underlying protocol. And what they write about Quick in their documentation is that it was not yet brought to a level which was useful for them. But as soon as Quick becomes more usable, they will be able to provide support as well. So yeah, I always try to advertise RSocket because it's very performant and not difficult to use, because Spring provides full support. You will see the interface clients, which make it super easy. And on server side, you can use the message mapping annotations, similar to the ones you use in messaging, to handle it on the responder. And yeah, it's very easy. So you will need the Spring Boot starter RSocket. And then our dedicated annotation is RSocket exchange, while in the responders, we use message mapping. Again, an interface, annotated methods. Here we have less options. So, for example, we had more attributes for HTTP exchange. Here we can only set the destination. So that is also the value that we will set on the responder side in the message mapping. And when it and that's the only one. We have one attribute. When it comes to what we can send, again, there are only few things. We have the payload. That is mostly what we are trying to send. But we also have a destination variable, which is a concrete value, and this is same as path variable. So if you have plus holders in your path, you can use this argument to set the actual URL. But this is neat. So RSocket uses the concept of metadata, which is similar to message headers, let's say, but yeah, it's referred to as metadata. It's a bit broader in use. And we also handle this. So for the RSocket metadata, you need to know what the MIME type is, and you need to indicate what the MIME type is. So for the interface client, if you give us an object which is followed by a MIME type, we know that is a metadata entry. Otherwise, if you just give us a non-annotated object, we will probably throw an exception. It's not something we handle. But if this is a MIME type behind it, we know that this is a metadata entry. So we will handle this as such. And that's what it will look like on the client side. And that's basically all. You just need one method call, and you can send these requests. It's a tiny bit more complex on the responder side. And I'm going to do this quick digression to the responder to show you how to read these metadata entries. So basically, in order to be able to handle this, you need to add a strategy. And in strategies, you need to set metadata extractor registry, and there provide the information, what MIME type you are looking for, what class you will be serializing this to, and what is the entry name or header name. I'm saying header because later in the message mapping on the responder side, you will use the header annotation or the headers one to get access to those entries. But yeah, basically, 2 method calls to get this done. And also look at the decoders and encoders in strategies. So if you have an RSocket application, it happened to me when I was starting with creating the demos and working with it. Whenever stuff just refuses to serialize and deserialize properly, you usually just need to add decoders or encoders to your strategies. Return values. So again, mono, flux, any producer that can be converted to a reactive stream publishers will work. And again, we can block this for you. Usually not a good idea. But yeah, if you know what you are doing, you can choose it, just not put the reactive type around it, and then we will just block it underneath. Again, super simple to instantiate. It's pretty much the same, so I will not be going into much detail because it's very similar. You will just need RSocket Service Proxy Factory instead of the HTTP Service Proxy Factory. And what is your client here, let's say? It is not exactly a client. It's called an RSocket requester, but it would do the same role as the web client, REST client, and so on in the HTTP interface. So you just create that, same as you would create it without having the interface clients, because again, this requester can be used to do calls similar as REST client can be used. But if you do this additional few lines of setup, you can later just use the interface and call the interface methods, and it's more readable. So then, yeah, you have your builder. You create this service proxy factory, passing the RSocket requester to it.
You build it. Again, you can customize it. Here, you can add also reactive adapter registry. And HTTP, you can still add it, but it's deprecated, so we'll be moving this. But yeah, again, the most important thing, you can add your own custom argument resolver. Just implement one method in the interface, and you can decide alone what to do with this. And again, not going into much detail, but since we allowed using the annotation for like server side and HTTP, here on responder side, we are also allowing to use these annotations. So you can have an RSocket controller that implements an RSocket interface clients. And then when you implement the method, you don't need to repeat all these annotations. And this will work. This is also one of the newer things we've added. And yeah, another topic, auto configuration. So actually, what we had in Fain or in Spring Cloud Square, most of it we are now able to handle with the Spring interface clients. And we have beyond feature parity for reactive scenarios and reactive types. We have feature parity for most of the other headers, parameters, etc., whatever you can do with your requests. We have feature parity in terms of providing load balancing and tracing. What we still lack is the auto configurations. And the users have been asking for it. So this is something that is now in the works. I've started working on it before I left for here, and that's going to be the first thing I will come back to. And then, yeah, I really hope we manage to get it in. So this is more of a trailer, some kind of questions or like considerations that we are trying to keep in mind while creating this feature, and I thought I would share it with you, so that you can participate in this discussion maybe, or have some other ideas. So first thing, if we want to add something like this, we need to think, how will we enable the auto configuration? How will we even tell it that we want to Spring to just start instantiating the beans for us and setting them up and so on? So with Fain, we use enable Fain clients. And that annotation allows you to specify, for example, specific classes or packages that you want to scan. And that kind of solution with a separate annotation is nice because of this, because it's more fine-grained. So you can tell them, OK, scan for me this, but don't scan that. So I want this client, but not the other one. You can pass some additional configuration. But it's another annotation. Maybe it's enough to have a property. That's something to think about. Another thing, how do we find the actual interfaces? Again, if we had that previous annotations, then maybe we just indicate there. But if we don't decide to go with it, then maybe we look just for the HTTP exchange or socket exchange annotated ones. But for example, in Fain, we had a Fain client annotation, and that allowed us to also pass the service ID and that we used for load balancing, and we used for circuit breaking, and also additional configuration. But again, this is another annotation. And while in Spring Cloud we provide an integration layer, and we are a bit more liberal with adding stuff, with Framework, since this is API and this is like core level, they have to be very conscientious. And also in boot, should we really have another annotation? So this is something to decide. If we create these annotations, where do they go? Since it's auto configuration, the configurations probably go to boot. But various similar situations are such that even when there is an annotation used for auto configuration, for example with data, that is used in boot, it still lives in Framework. So something to consider. Another thing, how do we find or create the underlying client? Because let's say I have an interface and I need a client. Now, do I set up the client in the auto configuration and then just use whatever I think is the best defaults? Or do I want the user to set up the clients and I just find them? And if yes, how do I find them? Should I use some kind of qualifier or maybe some kind of a naming strategy? Should we handle only one per client, or should there be a default that we can fall back to? And also, we could, once we have the client, we could just alone create the service proxy factory. But service proxy factory also has some possible configuration. So maybe we should also allow the user to create this one. So as you see, a lot of things to think about and consider. And then once we have found these clients or decided what they should be like, and we have decided which proxies we need, and based on which interfaces we create these proxies, we need to add bean definitions. And this, again, can be done in various ways. There is a very neat interface import bean definition registrar, which does exactly what it says it does. So if you want to import additional bean definitions, you can use it. But there is also bean definition registry post processor, where you can basically modify the bean definition registry. And then again, you can have a very simple bean definition or create factory bean. That's what we use in OpenFain. That allows you to do more setup and, for example, store the service ID and other details. And there are some existing implementations for auto configurations, especially for HTTP clients. So Maciej Walkowiak, that I'm sure many of you know, who is also the maintainer of Spring Cloud AWS and an awesome developer, has created one for HTTP. And yeah, I recommend you use it if you want to use something now. But obviously, this is, again, a kind of feature that is very close to our stack. So we would like to have something internal. So we have started working on it as a team. Josh Long has created a POC. And now we are having this kind of discussion and work to see how to adapt it to more scenarios and more complex scenarios. And probably we'll start there to provide the solution. And why am I doing this whole trailer section since I'm not showing you any code yet? This is because we have an issue. And if you're interested in this, you can participate in discussion. And once any pull request appears, it will be there by whoever, like link there, whoever creates it, whether it's me or anybody else. And then you can provide your own scenarios or your own ideas or criticize and write, no, this will not work because of such. So that's why I've added this section here. And a sample, OK. So there is a reason I'm calling it a sample and not a demo. And the reason is that since I'm not showing any complex setups of anything here, and I'm talking about APIs, the sample really just contains the APIs. So we have a service that does verification, and we have a client that uses interface clients to communicate with it over HTTP. As you can see, we are doing all the same things that were available in the presentation. And then we have a controller, which is a point of entry. So basically, we will use the client. If you hit this controller, we will use the client to contact the other service. And then there's the same thing for RSocket. So there is the RSocket verification, which has the annotated responder, and it's here. There are two, actually, one that implements the interface client and one that doesn't. And then there is another application that actually does the calls. And I've added a controller and HTTP as a point of entry, and also added a command line runner that will output the blocking value that would fail if I tried to do it from a controller, because we would be blocking on a thread where we are not supposed to block. And I figured that you guys know how to do HTTP calls, and that is probably not going to be interesting if I now start just calling these endpoints for you. So I decided that instead of demo, there is a sample, and this might be useful if you want to do this in your own project and set up your own interface clients, because most of the scenarios I've discussed, I've set up in the sample. You can also see the load balancing and non-load balance scenarios, how to instantiate it, any additional setup that we need for it to work, but mostly just all the possible usages. I think there's most that you can do with interface clients. So I will share the link to this when I share the slides, and I'm not going to try to call these endpoints now because, yeah, you can do this at home. It's the link. Yeah, I will also share the slides, so you don't need to take pictures, but you may if you want. And yeah, feel free to visit the Spring and Tanzu booth. There were colleagues such as Dashon and Dan, and I think Josh before, but yeah, people come and go, so you may find people from our team. And yeah, thank you very much. Yeah, we don't have much time for questions, but I'm very happy to take questions in the corridor or after it or through the app that comes or Twitter. Yeah. Do we have, okay, we have time for one question probably.
Yeah, thank you for the presentation. In Fain, there is a concept of a child Spring context, like you have an interface and nested configuration class, which you want to exclude from your main component scan, otherwise you will end up with bin overriding. And I've seen many people confused with that. So are you going to use this concept in your auto configurations?
Yeah, it is confusing. It was kind of difficult for us also when we were working with IoT. For example, yeah, so I think the team will be against using that same thing. We still want to provide the load balancing, but since we probably want these auto configurations to live in boot that has not been yet decided, we want to allow the users to set up their load balancing, and we may then just use the setup instances. So this is done underneath, but will not probably happen in the actual interface clients. And yes, I think I don't have more time, but I will stay here. So if anybody has any questions, I'm very happy to discuss. Thank you.